Good morning, students. Today we are going to discuss a few important topics from the chapter 2, Units and Measurement. The first topic which we are going to discuss is a combination of errors. Now, under the combination of errors, first of all, we are going to discuss error in sum. Suppose if you perform an experiment, what you have to do? You have to measure the few physical quantities. And after measuring that physical quantities, you have to substitute that physical quantities value in the formula to get the final result. For example, if you want to find the momentum, what you have to measure? You have to measure mass and velocity. So if you measure mass, there may be the possibility of earning error due to instrument, due to personal reason, and also you have to measure velocity. So due to the instrument or due to the personal reason or due to any other reason, there may be the possibility of earning error in measuring the velocity. So when you substitute these two values which contain error in the final formula, then definitely in the final formula you will get the error, and that error is nothing but the combination of the error of the two measured physical quantities. So your answer is not as per correct because both the physical quantities measuring parameter is not perfect, rather it combines certain amount of error. So that part we are going to discuss here. Suppose number 1, error in sum. Suppose in an experiment you have to use this formula, z equal to a plus b. So if you want to find z, what you have to do? You have to measure a, you have to measure b, and then you have to sum up to get z. So in measuring z, you have to measure a and b. So there may be the possibility that you will earn some error in measuring a as well as you earn some error in measuring b. So error is very small quantities, that's why we are trying to denote that error part with delta. Basically delta in physics, whenever we are going to use this symbol delta, it means the small value of that physical quantities. So if we write delta a, it's a very small value of a. If we write delta b, it is small value of b. So basically when you perform experiment, we try to find the value very accurately, but instead of that we used to earn some error. So that error part is very small, so that's why we are trying to denote that error part with the delta symbol. So in measuring z, you have to measure a and b. So if delta a and delta b be the error in the measurement of a and b, then the z accompanies certain amount of error that we have defined by delta z. So the error is nothing but more or less than the predict exact value, is not it? So if delta and delta b be the error in the measurement of a and b, then the error delta z in the measurement of z, finally it comes out to be z plus minus delta z. So delta a, delta b is the error in the measurement of a and b. So now when you substitute this error value with the physical quantities a and b, definitely will earn certain amount of error in the result, and that one is nothing but is your delta z. So error may be more or less, that's why final expression for z equal to a plus b containing error is nothing but is your z plus minus delta z instead of a plus minus delta a plus b plus minus delta b. Now next what we will do, we will separate the quantities a plus b plus minus delta a plus delta b within the bracket. So a plus b is your z, so z goes off left hand side and right hand side. Finally we will get delta z plus minus delta z equal to plus minus delta a plus delta b. So on simplification you will get delta z equal to delta a plus delta b. So what we have written here, hence the maximum possible error in z is equal to the sum of the errors in two quantities. So delta and delta b are the errors in the measurement of the two quantities. So maximum possible error is nothing but is your delta z. So delta z is nothing but the delta a plus delta b. It is nothing but the sum of the error in the measured quantities. So this formula delta z equal to delta a plus delta b we are going to use if you have to define error in sum. So if you use this expression in any experiment z equal to a plus b, then definitely the error part will be your sum of the error, that is the delta z equal to delta a plus delta b. Next one is your error in difference. So in an experiment you are going to use this formula z equal to a minus b, because you are performing many experiments, so in each experiment the formulas are not identical. Sometimes it is plus, sometimes it is minus, sometimes it is product, sometimes it is division. So all possible simplification part we are trying here. So if z equal to a minus b, the formula which you are going to use in an experiment, and delta a and delta b be the error in measurement of a and b. So for the error delta z in z, you will get z plus minus delta z equal to a plus minus delta a minus b plus minus delta b. So on simplification part, a minus b plus minus delta a and minus plus minus delta b within the bracket. So this is very simplified form, I think most of you know. So a minus b again z, so z plus minus delta a minus plus minus delta b. So z goes off, plus minus delta z plus minus delta a minus plus minus delta b. So minus plus minus is nothing but is your plus minus again. So plus minus delta a plus minus delta b. So delta z equal to delta a plus delta b. So hence maximum possible error is equal to the sum of the error in two quantities. So in error in sum and error in difference, the maximum possible error is same. That is nothing but is your delta z equal to delta a plus delta b. So I am repeating once again, delta we are using the small value. Whenever we used to define small value of any physical quantity, we use the symbol delta with that physical quantities. Now next one is your error in product. So in an experiment, let me try to use this formula z equal to a plus b. So can you say any expression which involves a and b? That is nothing but you can consider an example of F equal to ma. So if you want to find force, you have to find mass and acceleration. So z equal to AB. So if delta A and delta B be the error in the measurement of A and B, then for the error delta Z, you will get Z plus minus delta Z, A plus minus delta A, B plus minus delta B. So if you multiply AB plus minus A delta B plus minus B delta A plus minus, you will get delta A delta B, or you can write plus minus delta A bracket plus minus delta B bracket, then plus you can give, no problem. Now delta and delta B are identical. Delta and delta B is very small quantity. So if you multiply two small quantities, then the result is further smaller, because we are considering delta and delta B. These are the error in the decimal part. So if you can multiply two decimal figure, then the final result is further smaller. So delta A delta B product is neglected. So you will get Z plus minus delta Z equal to Z plus minus A delta B plus minus B delta A. So Z goes off, plus minus delta Z plus minus A delta B plus minus B delta A. So if you divide this expression throughout by Z equal to AB, then you will get plus minus delta Z by Z equal to plus minus A delta B by AB plus minus B delta A by AB. So on simplification, A goes off, B goes off. So you will get plus minus delta B by B plus minus delta A by A equal to plus minus delta Z by Z. So finally you can get delta Z by Z plus minus or simply delta A by A plus delta B by B. So hence maximum possible relative error, these are the relative error, is the sum of the relative error in two quantities. So this is in case of error in product. So I am repeating here, the final term delta A delta B product is smaller, that's why we are neglecting, because we are assuming that delta A and delta B is very small, or you can say delta is in decimal point, because you are performing the experiment very sincerely. That's why the error is there, but that value is very small. Now next one is your error in division. Let me use this formula z equal to A by B. So if you measure A and B, so definitely you will earn some error. So z plus minus delta z equal to A plus minus delta A by B plus minus delta B. So if you have to take A common, so 1 plus minus delta A by A, and denominator B common, 1 plus minus delta B by B. So A by B, 1 plus minus delta A by A, 1 plus minus delta B by B to the power minus 1. So Z plus minus delta Z, A by B, 1 plus minus delta A by A, 1 minus plus minus delta B by B. So here you are using the expression, the binomial expression 1 plus x to the power n equal to 1 plus nx. And if this is possible, if x is very less than 1. So if you consider 1 plus minus delta B by B to the power minus 1, then delta B by B is very smaller than 1, because delta B is the error and B is the actual value, is not it. So you can use this formula 1 plus x to the power n equal to 1 plus nx if x is very less than 1. So n is here minus 1. So you are getting z plus minus delta z equal to a by b 1 plus minus delta a by a bracket 1 minus bracket plus minus delta b by b within the bracket and further closing the bracket. So z plus minus delta z, a by b is your z. So we are expanding the product part. So 1 minus plus minus delta b by b plus minus delta a by a plus within bracket plus minus delta a by a second bracket minus plus minus delta b by b closed first bracket, second bracket and third bracket finally. So the third part neglected because it is further product delta a by a delta b by b. So you are getting z plus minus delta z by z, z plus minus delta z by z equal to 1 minus plus minus delta b by b plus minus delta a by a. So 1 plus minus delta z by z equal to 1 plus minus delta b by e plus minus delta a by a. So 1 goes off, delta z by z equal to delta b by b plus delta a by a. So finally you can get, hence maximum possible error in the sum is the sum of the error in the measured quantity. So product and division part is identical and addition and subtraction part is identical. So this is all about, you have to practice. So take pen and paper and try to simplify. This is simple mathematics, but you have to practice, otherwise it seems to be very tough. So this is all about in combination of error. One more part is there, we'll discuss next class. Thank you.